Students, good morning. Good morning to one and all. This is Professor Chetan Jadhav from Mechanical Department, Jain College of Engineering, Belgaum. Students, today we are going to start with the fourth module, that is CAMS. And this will be your first lecture on module number 4. In this, we are going to discuss with definition of CAM follower. After that, a detailed classification of these CAM and follower. So you can see towards your left side of the screen, these are the example of comment followers, and so you can see this cylindrical element which is rotating, which is having a groove. So it is one type of a cam. Okay, and you can see one more element which is reciprocating in left and right direction, which is nothing but a follower. Okay, here also you can see this image. It is also an example of a cam and follower, but you can see the shape of the cam is in the form of a concave shape, and it is having one groove, and with respect to that groove there is a one oscillating element you can see in this image, so which is nothing but a follower. Okay, so in the first image you can see the follower is reciprocating, and in the second image you can see the follower is oscillating. Okay, so based on different criteria, based on the type of motions of the follower or the shape of the cam and follower, we are going to discuss with different classification of these cam and follower. Okay, let me start with today's lecture. Just consider an image. So you can see here there is a circular disc, okay, which is connected to a motor so that it can rotate. And there's one more element which is in the form of a knife edge. It is in contact with this element. So I can call this as element 1 and this element 2. Just tell me what happens if the element 1 starts rotating, whether there will be any motion of this follower, because since the shape of this element is in the form of circular, okay, and this element 2 is in contact with this circular element, and there will not be any movement of this follower. Okay, if you are giving an input to this element 1, it will start rotating. The input motion is rotating type. But what about this output? There will not be any output, or there is no motion of this follower, because the surface in contact with this first element is in the form of circle. And in the second image you can consider, instead of a circular element, I'll consider an elliptical element. So it is also connected to a motor. Okay, again I'll consider this as a element 1 and this as element 2. So in this case, when the element 1 starts rotating, due to the non-circular nature of this element, what happens? The follower starts moving in upward direction, upward and downward direction. Just consider one point, that is point A on this elliptical element. Okay, as this element 1 starts rotating, this point A moves towards the follower. Okay, I'll call this as a cam and this as a follower. Okay, as the cam starts rotating, this point A starts moving towards the follower. Then what happens? Due to the non-circular nature of this element, the follower starts moving in upward direction. Okay, as the point A starts moving away from this follower, okay, after this, as the point A starts moving away from this follower, what happens? The follower will come down. So in the animation you can see, so this is nothing but a cam which is connected to a camshaft, and again it is connected to a motor. Okay, and the type of input motion is a rotary path. And you can see this one, so this is nothing but a follower, and you can see there is no a joint between the cam and follower. Simply there is a point or line contact between these two elements. Okay, so if the input motion is a rotary path, and due to the non-circular nature of this cam, the follower starts moving in an upward and downward direction. Okay, as I said, as the point A starts moving towards this follower, the follower will move in upward direction. As the point A starts moving away from this follower like this, what happens? The follower starts moving in a downward direction. So this is nothing but a cam and follower. Okay, So I can call this as a cam and this as a follower. So whatever you are seeing in the first image, this is not an example of a cam and follower, because the shape of this element is in the form of circle, and as this circular element starts rotating, there will not be any movement of this second element. So I cannot call this as a cam and follower. So if you want to call this as a cam and follower, there should be some input motion and there should be some output motion. Okay. So you can see these are the different examples of a cam and follower, different shapes of a cam and follower. Okay. So you can see the profile of this cam is different, or the pattern or the design of this cam is different. So here also you can see the outer periphery of the cam is different. Here also you can see the profile of this cam is different. So based on the applications and based on the output motion you want, based on that you are going to design the profile, the design of this cam. Okay, that is the intention of studying this module number 4. Okay, so these are the different profiles or designs of a cam based on what is the output motion required. So what is the speed of this follower which is required. Okay, and if you want a continuous motion of this follower, or in between you want some rest, so you can see the follower starts in the first image. So you can see in this image the follower will move in upward direction, again it will come down, it will take rest, again it will move up, down, it will take rest. Okay, but in this case in the second image you can see there's a continuous upward and downward motion of the follower. Okay, so based on what is the requirement, what is the requirement of the follower, so you are going to design the shape of the cam. Okay, and so then what are the applications of this cam and follower? I'll take a simple example. I think you can see this is an animation of an IC engine, correct? Okay, it is having 4-stroke and it is having a inlet valve and the outlet valve, correct? Or you can say a inlet valve and the exhaust valve. These are used to control the fuel which is going to enter and the exhaust gases which are going to move towards the outward direction. Okay, so these are the inlet port and the outlet port, and these are controlled by the inlet valve and the exhaust valve, correct? And the movement of this inlet valve and the outlet valve is again in turn is controlled by a cam and follower. So you can see in this highlighted portion, so this is nothing but a follower and this is nothing but a cam. So again this red color one, this also follower and this also cam. Okay, and you know that during the suction stroke of this IC engine, the inlet valve will be opened, correct? And at the last stroke, that is the exhaust stroke, this exhaust valve will be opened. Okay, it means you are controlling the motion of this inlet valve and the exhaust valve with the help of cam and follower. Okay, this inlet valve acts as a follower and this is nothing but a cam. It means the application is nothing but you are going to control the movement of the inlet valve and the exhaust valve as per your requirement. Okay, you can set the timing when it has to be opened and when it has to be closed. Okay, so this was one application of a cam and follower. There are so many applications of a cam and follower. You can search in the Google. Okay, so in the textile industries, in the spinning machines, okay, and in automobiles also, in aeroplanes, and in controlling the feed mechanism of a automatic lathe. Okay, so all are examples are applications of cam and follower to control the motion of different parts. Okay, then after this we'll see what are the different types of motions of the follower. Okay, so this is nothing but a cam which is connected to a camshaft, and this is a follower. Okay, since the shape of this follower in the form of a roller, I can call it as a roller follower. So let me see the animation of this cam and follower and why it is called as a reciprocating motion of the follower. Okay, so you can see why it is called as a reciprocating type of the follower. Just watch this video. So you can see the input motion is a rotary path and the output is a reciprocating type. The follower is moving in upward and downward direction. Since the output motion is in the form of a reciprocating type, so I can call this particular type as reciprocating type cam and follower. Okay, just mainly concentrate on the output motion. Just concentrate what is the kind of output motion you are seeing. The output motion is in the form of reciprocating type. Okay, and I'll consider one more image. So it is also a cam and follower. Just try to concentrate on the output motion, how it is. Just watch this video. So you can see the input motion is a rotary path, okay, and the output motion is oscillating type. Okay, the follower is oscillating. You can see here it is oscillating from left to right and right to left. So this particular type of cam and follower is called as oscillating type cam and follower, right? So mainly I wanted to differentiate between what is the reciprocating type and the oscillating type, so that I can define what is exactly a cam. So we'll go with this, the definition of cam. After seeing all these animations, I can say that a cam is a rotating machine element which gives a reciprocating or oscillating motion to another element known as follower. It means you can see in this animation, the cam is a rotating machine element which gives a reciprocating or oscillating type of motion to another element. The another element is nothing but a follower. This follower is going to follow this cam. Okay, you're going to give the input motion to the cam and the output motion you will get from the follower. And what are the features of these cam and follower? The first one is the cam and follower have a line contact or a point contact and hence forms a higher pair. You know that if there is a line contact between two kinematic links or element, so I can call it as a higher pair. In this animation you can see the type of contact between the cam and the follower is a line type. Okay, it means the type of pair is higher pair. This is one of the feature of this cam and follower. And one more is the contact between the cam and follower is always maintained with the help of a spring force and a self weight of the follower. So in this animation the spring is not visible. Better I can show with one more animation so that it will be clear. Yeah, you can see in the previous slide, that is a reciprocating motion of the follower. So in this you can see the contact between the cam and the follower is maintained with the help of a spring force. You can see there is a spring which is attached to this follower, so that I can maintain a constant contact between a cam and the follower. Okay, that is the use of this spring force. Okay, and you can see the cams are usually rotated at uniform speed. So from the animation you can see that the motion of this cam is uniform. It is moving with uniform speed. Okay, but the follower motion is not with uniform speed, and the follower will not be moving with a constant velocity or the speed. Sometimes it will be moving with 5 centimeter per second. Sometimes it will be under rest. Sometimes it will be 1 centimeter per second. Okay, it means the cam will be having a uniform speed, but as in the case of follower, it is not uniform. Okay, after that, what are the basic components of this cam? The cam and follower is having three basic components. That is, first one is cam, which is nothing but a driving member. Since the input motion is connected to this cam, so I can call it as a driving member. The cam is nothing but a driving member. And this second element, that is a follower, I can call it as a driven member, because the motion of this follower is controlled by this cam. Hence the follower acts as a driven member. And what about this frame? So you can see this guide wheel or the frame. So this is nothing but a frame. which supports this cam, and also it guides the follower so that the follower moves in a definite direction. Okay, so whatever there is a fixed element. You can see this one, and the spring also comes in this frame itself, so it acts as a supporting element, and also it guides the follower. I think this is clear. The definition of cam is clear. So finally I can say that a cam is a rotating machine element which gives a reciprocating or oscillating motion of another element known as follower. So as I said in the previous slide, the output motion may be of oscillating type, and and the output motion may be reciprocating type. So that's why I said a cam is a rotating machine element which gives a reciprocating or oscillating motion to another element. So this another element is nothing but a follower. And these are the features of this cam. The cam and the follower has a line contact, and the contact between these two is maintained with the help of a spring, and this cam is going to rotate with uniform speed, but as in case of follower it is having a non-uniform speed. And these are the three basic elements of this cam. First one is a driving member, the second one is a driven member, the third one is supporting member, or it acts as a guiding element. And if you want to take the actual image of this cam and follower, just I'll open this PDF. Yeah, so in the examination you can draw this image. So this is nothing but a cam and follower. It's a cam, it is connected to a camshaft, and this is a knife edge type of a follower which is attached with a spring. Okay, and so this spring is used for maintaining a proper contact between the cam and follower. And this is a third element, that is a guide or the frame, which guides the motion of the follower. And you can see the direction of motion of the cam. It may be a counterclockwise or the clockwise. And the output motion may be in a reciprocating type, and in some case it may be of oscillating type. You can see in this image the motion of the follower is in the form of oscillating type. Okay, and after this we'll start with the classification of the followers. Based on different criterias, we'll start with the classification of followers. Students, just note down different classifications of the follower. According to three criterias, I'm going to classify the followers as a knife edge follower, a roller follower, flat faced follower, and a spherical faced follower. So all this comes under according to shape of the follower. Okay, based on what is the shape of the follower. If it is a knife edge, so I'm going to call it as a knife edge follower. If it is a roller, I'll call it as a roller follower. And if the shape of the follower is in the form of a flat face, so it will be the flat faced follower. And it is if it is a slightly a spherical shape, so I'll call it as a spherical faced follower. Please note down these classifications so that in the next slide I'm going to start with this knife edge follower. Okay, so first I'll go with this one, that is a knife edge follower. I'll show some animated videos so that it will be clear. Just take 30 seconds and just note down what are the different types of followers based on three criteria. First one, according to shape of the follower. Second one is according to the motion of the follower. And third one is according to position of the follower. So we'll start with the first one. Okay, so just try to see this animation. Okay, so this is nothing but a cam. Okay, just don't worry about the cam, only just concentrate what is the shape of the follower. So this is a follower which is connected with a spring, and these are the frames. Okay, let's try to watch this animation. And you're seeing the input motion is reciprocating, the output is also reciprocating. And why it is called as a knife edge follower? Because the shape of this follower is in the form of a conical shape or a knife edge. Okay, so I can call it as a knife edge follower. It means if the contact end of the follower has a sharp edge, then it is called as a knife edge follower. And you can see the sliding motion takes place between the contacting surfaces of the knife edge and the cam. You can see there is a sliding motion between a follower and the cam. And since uh, it is having a knife edge, there may be a chances of excessive wear, because as a small area of the follower is in contact with this cam, there is a chances of a wear and tear of the cam as well as follower. And if you want the actual image of this knife edge follower, so you can go with this one. So in the examination you can draw this one. The examination you can draw this one. So this is nothing but a cam. This is connected to a camshaft. It may be rotating either in counterclockwise direction or in the clockwise direction. And to this cam there is a follower which is in the form of a knife edge. So I can call this as a knife edge follower. And the type of contact is a point contact. Okay, since it is having a sharp edge, there may be a wear and tear of this cam profile, cam surface. Okay, again the type of input motion is a rotary path. The output motion is reciprocating type. Okay, so this is the first one. If you want, you can take this image. Otherwise, after the class, I'll share this PDF in the Google Classroom. After this, I'll start with the next one. That is a roller follower. Okay, you can see in this image the type of follower is in the form of a roller. Correct? It means first I'll show the video so that it will be clear. Again, the type of input motion is a rotary path, and the output motion is a reciprocating type. But only the difference is the shape of this follower is in the form of a roller. It means if the contact end of the follower has a roller type, then it is called as a roller follower. And compared to the knife edge follower, the wear and tear is less, because the type of contact is in the form of a line contact and it is having a roller shape. The wear and tear of this roller follower and the cam is less compared to knife edge follower. And these followers are widely used in aircraft engines. Okay, these roller type of followers are used in aircraft engines. If you want the actual image, the schematic image of this follower, so you can see in this image. So this is nothing but a roller type of a follower. Okay, again this is a cam, and this is a camshaft which is connected with a motor, and this is the follower, and at the end of this follower there is a roller which is in contact with this cam. Okay, since the type of contact is a roller type, so the wear and tear is less compared to knife edge follower, and it is used in aircraft engines to control different motions of different mechanical elements. So you can use this in aircraft engines. This is about the second one, that is a roller follower. Roller follower. Just wait for a second. So after completing the knife edge follower and the roller follower, we will go with the next classification, that is a flat faced follower. So these are nothing but a flat face or mushroom type of follower. Okay, so this is the third classification of the first criteria. So in this image, again you can see an animated video. The type of input motion is again a rotary type, and the output is reciprocating. But I'll concentrate on the shape of this follower. Since the shape of this follower is in the form of a flat face, so I can call it as a flat faced cam follower. If you want, you can see one more time. The shape of the follower is in the form of a conical and with a flat surface. Okay, and if you're going to modify this flat face slightly with a circular path or a curved path, okay, so it is also called as a mushroom type. If you're going to modify this flat faced follower with a small curvature at the end, so it'll become a mushroom type of follower. Okay, both are same, only a small modification in the curvature. Instead of a flat face, it is having a small curvature. Again, the working principle is same. The input is a rotary path and the output is reciprocating type. If you want the actual image of this flat faced follower, so you can go with this one. Okay, so in the examination you can draw this one. Okay, and the explanation is again same, only you are concentrating about this shape of the follower. Okay, it means if the contact end of the follower is perfectly flat, then it is called as a flat faced follower. Okay, and again compared to the knife edge follower, the flat face follower is having more wear and tear, because the larger amount of this follower is in contact with the cam. It means the relative motion between these surfaces is largely of sliding nature. Okay, you can see the size of this flat face follower is more compared to the knife edge follower. Okay, hence the type of contact is again the sliding type, hence the wear and tear is more. So that to avoid that, so slightly you can offset this follower. You can change the axis of this follower with respect to the center of this cam rotation. Since in this case both are in the same line, okay, so slightly you can do the offset of this follower and you can reduce the wear. Okay, and this is about the third one, that is a flat faced or a mushroom type of a follower. And if you are going to go with the next one, that is a spherical faced follower. Okay, so you can see in this image it's similar to a flat faced mushroom follower, but the shape of this follower is in the form of a sphere or a spherical face. Okay, the shape is spherical, that's why it is called as a spherical faced follower. It means if the contact end of the follower is of spherical shape, then it is called as a spherical faced follower. Okay, and this is utilized to reduce the stresses which are generated in the flat faced follower. Since in the case of a flat faced follower, the wear and tear is more, and there may be chances of induced stresses in the cam. Okay, to avoid that, So this spherical phase follower is used. It means when a flat phase follower is used in automobile engines, high surface stresses are produced. Okay, the stresses which are produced in the cam profile are more in the case of a flat phase follower. To avoid that, to minimize that, we are using this spherical shaped follower. Okay, it means to minimize these stresses of the flat end of the follower, so it is converted into spherical shape. So that is the only modification. Okay, so this is about a spherical phase follower. If you want the animation, you can see this. And before that, so this is the flat phase follower, and this is the application. The automobile engines, the IC engines, to control the inlet valves and the exhaust valve, the type of follower is used is flat phase follower. And since it is having more wear and tear and more surface contact, which is in the form of a sliding motion, to avoid that, we are going with the next one, that is a spherical phase follower. So as explained, you can see the shape of this follower is in the form of sphere. You can say as a hemisphere. Okay, you can see better animation. Again, the working principle is same, but only the shape of this follower is in the form of a sphere, or you can say as a hemisphere, so that you can minimize the stresses which are going to induce in this cap. Okay, it is also used in automobiles. So this is the application of this spherical follower. So this is a spherical follower. So instead of can see the instead of a flat follower, it is replaced by a spherical shaped follower. And this one is a cam. Sorry, this is a this is a cam, and this is the inlet valve. This is also a cam, and this is the outlet valve or the exhaust valve. And the shape of this follower is in the form of a sphere, so which is used in automobile engines, okay, to control the inlet valve and the exhaust valves. Okay, so by using this one, we can minimize the stresses which are going to induce in the cam as well as in the follower. So that is the only difference between a flat faced follower and a spherical faced follower. After this, we'll go with the second classification according to motion of the follower. Okay, please note on this one. According to the type of motion of the follower, we are going to classify the cam and follower as a reciprocating type, and one more is oscillating type. One more is oscillating type. Please note down the second one. This is the second classification. That is a reciprocating follower and oscillating follower. First, I'll start with this one. That is reciprocating follower. So better I'll show the animation of this reciprocating follower. Just concentrate on the output motion. The output motion of the follower is in the form of reciprocating type, which is moving up and down. So I can call it as a reciprocating follower. Okay, but in the case of the second video, you can see second animation, the type of the output motion is in the form of oscillating type. Okay, the input may be a rotary type, but I'm going to consider the output motion. Instead of a reciprocating type, in this case it is oscillating. It means based on the type of motion of the follower, I can classify into two types. One is a reciprocating follower and one more is oscillating follower. So this is the difference. And if it is clear, I'll go with the next one. That is according to the position of the follower. So according to the position or the axis of the follower, I'm going to classify as a radial follower and offset follower. Please note down these two. I'll try to differentiate what is exactly a radial follower and offset follower. Okay, so this is the third classification. So that is the third criteria based on the position of the follower. First one is the radial and the second one is offset follower. So this one is nothing but a radial follower. What is exactly a radial follower means? The axis of this follower, okay, is in line with the center of the cam. So this is the center of the cam, correct? It means if the axis of this follower is in line with or is along with the center of this cam rotation, so I can call it as a radial follower. Okay, also can see the direction of the motion of this follower is perpendicular to the axis of the cam. The axis of this camshaft is perpendicular to this screen. Okay, it is perpendicular to the screen, and the type of the axis of this follower is perpendicular to the camshaft, and it is passing exactly through the center of this cam profile or the camshaft. So that is why I'm going to call it as a radial follower. And in the second image, you can see second image. So this is nothing but the axis of the follower, and this is the center of this cam. Okay, you can see there is a slightly offset. It means the axis of the follower is not in line with the center of this cam. There is a slightly offset towards right, so I can call it as an offset follower. So this is very important. So we are going to solve some problems on this radial follower as well as offset follower. If you want animation, you can see the animation. The axis of the follower is in line with the center of this camshaft. Also, it is perpendicular. You can see the axis of this cam is perpendicular with respect to the axis of this follower. Okay. The second animation, you can see there is an offset between the axis of this follower and the center of this camshaft. Okay, there is a slightly offset. That is the only difference. That is the only difference. Okay. These followers are also used in automobile industry or aircraft industry. So based on the space restriction, if the space restriction is very less, you can go with this one. Okay. And if the space is more, and if you want to minimize the wear and tear between these two elements, you can go with this offset follower, so that you can avoid the maximum contact between these two elements. Okay, if there is a less contact, there will be a less wear. Okay, based on the space restriction and the amount of wear and tear, you can select either a radial follower or the offset follower. If you want the exact animation or the exact image of these two, you can go with this. Okay, so you can see this is nothing but a radial follower. This is the axis of the follower, so which is in line with the center of this camshaft. Okay, and this is nothing but the axis of this cam. Okay, so both are perpendicular. Both are perpendicular. And in the second case, that is the offset follower. There is a slightly offset between the axis of the follower. You can see here. This is nothing but the axis of the follower, and this is nothing but the center of rotation of this camshaft. There is a slightly offset towards your left, so I can call it as a offset follower. Okay, this is about the classification of followers. Okay, and the last one is okay, this one. Okay, we completed all the three. Classification of followers based on shape, based on the motion of the follower, and the position of the follower. Quickly, I'll revise once again so that if any doubts, I can clarify. Yeah, the first one is the knife edge. You can see the shape of the follower is knife edge, so I can call it as a knife edge follower. And second one is a roller type, and it is called as a roller follower. And the third one is nothing but a flat face or a mushroom type. The end of this follower is perfectly flat. I can call it as a flat face. If it is slightly a curved shape, not a spherical, if it is a slightly curved in nature, I can call it as a mushroom type. So these are also used in automobile industry to control the motion of different mechanical elements like inlet valve and the exhaust valves. So this was the application. Okay, the flat face follower which is used in IC engines to control the motion of this inlet and the exhaust valves. The next one was the spherical face follower. The shape of the follower is a hemisphere, so I can call it the spherical face follower. To avoid or to minimize the stresses which are going to induce in the case of a flat face follower, I'm going to use this one, that is nothing but a spherical face follower. So again, you can see the application of this spherical face follower in automobile engines. And the second criteria is based on the type of motion of the follower, that is reciprocating and oscillating follower. So in this case, it is having a reciprocating type, and in this case, it is having an oscillating type. And after that, we have discussed the last one, that is according to the position of the follower. It means if the axis of the follower is in line with the center of the camshaft, it is called as a radial. If it is a slightly offset either towards the right or left, it will be called as an offset follower. Just remember these two. These two are very important from the exam point of view. So on this radial follower and the offset follower, you are going to design this cam profile. And this is about today's class. And in the tomorrow's class, I'll go with the classification of cams on different criterias. Okay, again there are three criterias. So far we have discussed the classification of followers. Okay, the next class I'm going to discuss with the classification of cams based on these three different criterias. Okay. If there is no doubt in the classification of follower and the definition of cam and follower and applications, and I'll wind up today's class. Okay, thank you.